So this is going to be our second video on square roots and how to simplify these radical expressions. And I'm going to show the same number twice because I want you to have a better feel for there is more than one way to solve these questions. So I'm going to start out with the square root of 18 for both. On the left, I'm going to do the more quick and direct route. On the right, I'm going to do the process that is still correct. It might just take a little longer. So if I want to look at these numbers, my first goal is to determine is there any perfect squares that go into 18. So I'm thinking of numbers like 4, 9, 16, 25, so on and so forth. And I know that 9 is a factor of 18. So I have the square root of 9 times the square root of 2 is equal to the square root of 18. And I like 9 because 9 is a perfect square. So to simplify this square root, the square root of 9 is 3. And then I look at the square root of 2, which can't be simplified, so you just bring it down next to whatever you took out of the radical symbol. Oops, I don't know why I just put a 2. 3 times the square root of 2. On the right side, let's say you didn't think of any perfect squares, but you knew that 6 and 3 were each factors of 18. So you wrote down the square root of 3 and times the square root of 6 is equal to 18. 3 is a prime number, so we don't want to worry about breaking this down any further, and we also know it's not a perfect square. Then I'm looking at 6. 6 is a composite number, so I can continue to break it down with other factors. And I know that I have the square root of 2 times the square root of 3 is equal to 6. So now I've broken down this factor tree as far as it can go. I don't have any perfect squares, but I do have 2 square roots that are exactly the same, which is the square root of 3. So what you're allowed to do is, when you have 2 of the same, you just take out the number from the radical and put that in your answer. And then I can just throw the square root of 2 right next to it. And you're done. And notice it's the same answer. So if you can't think of perfect squares, but you see that there are pairs within your factor tree, that can help you to simplify your answer. I'm going to leave this one up on the left, but I'm going to just erase this and do a different example. Let's do the square root of, let's do 32. Now, if I want to use this example, off the bat, I think of perfect squares, and some of you probably are going to start with 4 and 8, because 4 times 8 is 32. And that's fine. You can start out with those two, because 4 is a perfect square. Some of you might be thinking, well, there's a bigger perfect square that goes into it, which is 16. And if that's the one you're comfortable with, that would be the work that you would do instead of this right here. So I would go ahead and see that 4 is a perfect square, so I can take out a positive 2. And then I see that 8 isn't a perfect square, but I can continue to break it down further, and I'm left with the square root of 4 times the square root of 2. Once again, I see that the square root of 4 is a perfect square, so I can take out a 2. When you take out more than one thing from a radical, you multiply those whole numbers together. So I took out 1 2 from the first square root of 4, and now I'm taking out another 2 from the second square root of 4. And I'm going to multiply them together in my simplified answer, and then I'm left with the square root of 2 at the end because that can't be simplified. So then to finish this out, 2 times 2 is equal to 4 times the square root of 2. And that also makes sense because if you didn't pick up on 4 being a perfect square, but you noticed you had a pair of 4s, you're allowed to take that out as well. So if you notice, there's a lot of different ways to get to the same answer. Now, dealing with variables, those can become tricky because you have to remember your exponent rules when it comes to multiplying the same base and how to combine their exponents. And what I hope you remember is that when you multiply the same base, you add the exponents. So x squared is an example of a perfect square when it comes to variables. Because if I multiply x times x, or x times itself, x times x is equal to x squared because you add the exponents of 1 and get 2. X to the fourth is also a perfect square because I'd be multiplying x squared times x squared. And 2 plus 2 is 4. And we're multiplying the same exact thing by itself twice. Another example, I'll go up to x to the 6th, even though I don't think many of our questions go up that high. I know that it's a perfect square because x to the third times x to the third is equal to x to the sixth. I tend to focus on using x squared, x to the third, and x to the fourth. So to put that into practice, let's say I give you the number, let's do 24x squared. What I like to do, and again, it's just a preference, is break out the 24 and the x squared into different sections so I can simplify them individually and not forget something. Oops. Okay. So first I'm going to start with 24. And again, you want to think of perfect squares. And I know that 6 and 4 work because 4 is a perfect square. So I see that 4 is a perfect square and the square root of 4 is 2. And then I see that I can continue to break down the square root of 6 into the square root of 3 and the square root of 2. Now, neither of these are a perfect square, so I don't need them. I would just write down the square root of 6. When that happens, when you're left with a number that's not a perfect square, even though it can be broken down, that doesn't mean it's going to be used to simplify the question. So the square root of 6 is just left. There's nothing I can do with it. And actually, you want to move it over. So I simplified the numbers as best as I could. Now I'm looking at x squared, and I know that's a perfect square because x times x is x squared, so I would just be taking out an x. So I took out a 2 and an x, and I'm left with root 6 because that can't simplify anymore. And you're done. If I gave you, let's use the same exact example, let's do 24, but let's do x to the third. Number-wise, we'd still be left with 2 and the square root of 6. So I'm going to write that down, 2 and the square root of 6. But now when I'm breaking down x to the third, the only way I can break that down is multiplying x times x squared. Now x is not a perfect square, so it has to stay in the radical, but x squared is a perfect square, so I'm allowed to take out an x. So the variables are done the same way numbers are. You just have to be careful of how you actually break down the numbers. It's adding the exponents. I guess to just show you a couple examples of numbers that are not perfect squares, but they look like they would be. So you kind of have a heads up of you don't have to worry about simplifying them because it doesn't work. I'll start to write some down. I'll leave that one up. The square root of 6 is not a perfect square, and it can't be reduced any further to create one. The square root of 14, because all you have is 7 and 2. The square root of 21. Now, it doesn't mean don't break these numbers down, but it's okay if in your final answer you're left with something like the square root of 21 or the square root of 6, like we were here. It just didn't help us to simplify the question any further. I know this is a lot of information and I know it's rather difficult, so please utilize your textbook and I will look to see if I can find other videos to post. Good luck.